everyone. Thanks for coming. So let's start our afternoon panel discussion here. I think it's about a topic which I think everybody should be pretty excited about, which is structure versus scale. How are we going to solve all of our robotics problems, and which one's better? So I'm going to ask all our panelists to go around and introduce yourselves and give us your opinion. So which one's better?
I guess I'll start. Hi, my name is Evan Morikawa. I work at Generalist right now. Before this, I led engineering at OpenAI, leading our applied engineering team. Scaled API, ChatGPT. Now see this kind of whole AI system starting again in robotics. I think this kind of colors a lot of my impressions about this. I very much believe that we can crack this problem as a function of compute and data. You know, our guest Wi-Fi password is "I have the courage to scale." I think with that can come intelligence.
Hi, John Betancourt here from Cubibot, and we'll be also soon known as Robot.com, where we believe we can automate the world. I work with autonomy of our sidewall delivering drones. And what was the question about?
So which one's better, end-to-end or modular methods for solving autonomy?
Which one is better? Well, I will say that modular right now, but because it's what we have now deployed. Of course, a lot of the challenges facing every day. But of course, end-to-end as the future with own challenges. But for now, I would say modular.
Okay.
Hello, everyone. My name is Shitij Kumar. I guide the motion grasping intelligence and simulation infrastructure at Dexterity. We build AI-powered logistics robots, and we've been building small and large scale deployments, and we've been doing small and large scale deployments in production for quite some time, including palletization, depalletization, truck loading, unloading, singulations of parcel for the past 8 years, and mostly my take right now is that it's a compositional or modular approach or layered AI approach works better currently, but we'll see how the future holds. Yeah, thanks.
Hello, I'm Adolfo at the Bot Company. We're building robots to give you all time back. Before that, I spent several years working at Cruise on self-driving, and I'm personally very bullish on the end-to-end approach, seeing the progression over the last five plus years in moving to deep learning systems across autonomous stacks and pulling these components together over time. I'm super optimistic that we will continue to drive up scale and get to the end-to-end approach across the board in the near future.
Great, okay. So now that we've got everyone introduced, we're going to start with a couple general questions. I think we've already got some hints of what people believe from this, probably. But okay, so to start out with a straightforward question, what does the robotic stack of the future look like? How are we going to solve our problems in 5 to 10 years? So Evan, do you want to go first?
Yeah, I actually think we do have the stack right now. I mean, we believe in kind of the end-to-end approach here. Our stack looks pretty similar to what, like physical intelligence shows, what like NVIDIA has been pushing here. The architectures are the same. I mean, these are the same systems that drive ChatGPT. They are the same architectures. Believe that within limits, a token is a token here. It can represent, these are understanding the world, they're understanding physics. I really do believe that at this point, it is a function of, if you can get enough data to train these models and put enough compute into it, you can have a similar level of abstraction and generalization and reasoning that the current systems have. Now, there will be a lot of little tweaks along the way, and I also do believe in the power of harnesses on top of the models. You need to be more than a model weight. So I guess I'm not all the way on the end there. Analogous, but I think this is very analogous to what you see in language models as well. Cursor is successful because you both have a really successful underlying model and the harness on top of it that makes it useful. But the architectures have been the same mostly since the early days of GPT-2 and GPT-3 with a lot of tweaks to scale up. So I actually do think we have the fundamentals today. I think this is happening soon. This is like whoever gets enough data and throws enough compute at it first and kind of puts all the other pieces together will start to show this kind of truly general purpose sort of robotic intelligence that we're hoping for here.
Okay, well, I don't want to derail things already, but you're talking about building harnesses on top of these. aren't those already providing structure and modularity?
Yeah. So I do think that there is a balance of this. So I don't think you can just be a brain. I do think this needs to be a fully integrated approach. There's also why, at Generalist, we think it's important to actually go to an end customer here. This is influenced by two things. One, I'm very biased in my days at Applied. The way the models worked, we thought they worked at OpenAI was very different to how they ended up in the real world. And there's some examples of this. For example, early on, to make it output JSON, we had to add sort of syntax parsing onto the API to make sure it stayed on track and outputted JSON. But as the models got better, you didn't need that anymore. You didn't need these types of crutches and harnesses to do the job, but you still needed to have an end-to-end solution. I think we will see something analogous. I think the general purpose models will give you a base foundation, but to make an application that's specific, you need a little bit of harnessing on top of that to make that useful in the end, and that informs the model itself. It is an important feedback loop. And as the models get smarter, the nature of that harness will ideally dissolve away more and more and change over time. There is a balance, though, as to how far down this rabbit hole you go. Here again, in the LLM analogy, there's a company like Harvey who has a distinct business for lawyers because it has taken a lot of harnessing to make it useful for lawyers. That is not, ChatGPT itself is a type of harnessing that makes it useful for consumers. And this does matter, but sort of in a play to be more general purpose, figuring out that right level of abstraction is going to be kind of a constant battle that is going to be a function of the users in the market and how smart the model is. So I think it's going to be very difficult to predict kind of until you're there and can iterate on it.
Okay. All right. Cool. Well, I'm sure we'll talk more about this. John, what's your take?
Okay. Many robotics applications like ours already use different neural networks for decision making in critical parts of the daily operations, such as crossing streets, helping perception for cost map populations, and others. So I think not general, but neural networks for specific tasks are working together are happening now. And as I see end-to-end approaches evolving, gaining our confidence to be deployed will be something progressively. Maybe someday, I hope so, because of the promise of the things will be easier and simpler. End-to-end models will be another module or item in our modular robotics system. I think in the long term, 10 years from now, we see the opposite, when end-to-end models will be controlled and restricted by other components, and this more for safety reasons, not because of performance. Whatever, I think with the prime minds working behind on this, probably we won't wait until 10 years for it.
Okay. Shitij?
I think the question we want to ask is we want a robotics stack that is reliable, robust, and it's getting the job done that you want to have the intention of the robot be. We want that kind of robotics stack. Whether it turns out to be a smaller neural networks put together in a compositional layers of AI, or is it an end-to-end neural network? That's a question of how we're going to get there. But at the same time, I think we need a robotics stack that allows us to build things that are good to scale, start providing incremental value as we go, and grow into something and evolve and have the ability to evolve. So basically saying that, okay, I'm out there, I'm doing the task there. I'm not able to do probably the 100% of the task, but whatever I can do, I'm getting enough data to being able to understand that particular situation or the particular environment that you're operating under. And so I think what I strongly feel and believe is that you want to get, based on the applications, it's very application specific for sure, what problem you're solving, because at the end of the day, the customer that you're trying to solve it for, they will not care whether it's a modular approach or an end-to-end approach. They will actually care about KPIs and bottom lines that are at a macro scale, right? What is moving the needle at the end of the day? Who's getting affected of it? So I think we want to, and that's why I think when we are building robotic stacks for the 5 to 10 years, would be everything around it and and the core technology stack itself. I think that's, and being able to grow with it. And let's say you have, and we have specific skills set for this particular job that you are doing for a particular customer. Next say the customer asks you, or like in environment, and ask you, oh, can you do this also? Can you do this also? I'm going to throw you some other environmental complexity. Are you operating inside, let's say, a truck? Can you operate inside a container or some other operations? You need to have a stack build that adapts to it, is able to be able to do it. At Dexterity, we have found that the approach of creating these layers of AI, whether they are skills that are completely algorithmic or neural network trained, doesn't matter. I mean, and maybe later on, as you collect more data, they will transform into that and be able to eat your own code base to do it. Sure, I'm all for it. But right now, the main goal as you build out is a stack that is able to evolve, able to monitor, have some guaranteed transactional guarantees about what it's supposed to do under certain specific.
So just to make sure, to rephrase, to make sure that I understand the argument. So customer requirements are going to be changing, environments will change, and so because of that, its modular stacks will scale better over the near term. Is that kind of the argument?
Yes.
Okay.
In a way, yes.
All right. Okay.
So I guess my take probably extends beyond just the stack that's on the robot. If I'm super bullish about the end-to-end approach, then I think Evan makes a very clear point that the model you're putting in the robot conceptually may not change very much. But I think the biggest things that I expect to see change over the next 5 years is how do we create that model? So the first one is, as you scale your deployments, how are you learning from your massive scale data collection in the field? There's been a lot of work put into how we learn in the LLM space. We're going to be learning a lot in the physical world space, especially as this data becomes more and more semi-supervised to unsupervised, because you're just not going to label at that scale. And for the most part, these robots will be doing autonomous tasks. The second big thing I think about is how do we get the density of supervision to learn from all the data we're collecting? If you have an individual sample come in and you're only learning one thing from it, the density of your learning is way lower than if you can learn 10 things from it. So as you get into these diverse environments at scale, how do we learn 10 things from each data point we create? And then the third piece of it is the quality piece. And I think that's the last thing that we've seen in the LLM scale up is, yes, to a large extent, massive scale pre-training matters a lot. But from an alignment and fine-tuning perspective, to some extent, you do still have the problem of garbage in, garbage out. And so if you want your robot to do really high-quality behaviors at these scales for your users, you do need to think about how do you refine down to that super high-quality piece to ensure that the behaviors the robot has learned to perform match the quality expectation that your consumers want. So I think as we see things scale over the next 5 years in the end-to-end approach, those are going to be the three big levers we're going to be pulling on and evolving the most, especially as we get into these regimes where companies start talking about tens of thousands, hundreds of thousands of robots deployed in the world, because that looks vastly different than anything except maybe ADAS systems are hitting with, or I mean Tesla, whatever you're going to call that, is hitting with the scale of deployment.
Sure. All right. So since you're talking about improving the customer experience and all this, let's go do a follow-up question that I think that we'll ask everybody. But this is basically why doesn't this work right now? What do you need to get your system to that point?
Yeah. So I think the biggest thing is for any deployment, you don't want to dissatisfy your customers first. So you're not going to put a crummy product into the world. Otherwise, you lose your customers immediately. So the thing you really need is the baseline performance of whatever number of nines you need to get them initially satisfied and hooked to keep scaling this. And one is bootstrapping that in-house, right? So continuing to scale up your data. You have to get to a certain floor before you can get it out in the wild. The second thing is evaluations. Evaluations is probably the hardest thing I see in robotics today. If you know how to evaluate your system and you know what's good and bad and can clearly quantify that in your metrics, in your training, in your open and closed loop evals, it's way easier to solve the problem than if you haven't solved the evals. So that's probably the biggest gap I see today, besides the data scale up, is evaluations and how we nail those as an industry, because I think that's holding us back the most.
Okay.
I think it's just data. I think data insufficient quantity, quality, and diversity. If you had all three in abundance, I think it'd be done. Then it would turn into a function of compute, which is where the LLMs are now. But if in the robotics space, there's sort of a limit there. And I think actually anyone who has currently made this work so far had that advantage of having like a very large amount of like diverse, high quality, curated data in large amounts. Like in a sense, I think the places that end-to-end is working really well now, like full self-driving, Waymo, had this huge advantage to drive millions of miles of data collection to do that. Like the quantities of data are just orders of magnitude bigger than what like a couple humanoids have teleop so far.
Do you have a response there?
Yeah. So I think I'll say like to make a system work in production, like you have your core technology component. Don't get me wrong. How you make it is getting the core work done. That's great. But there is a lot of things that go around it as well. There is your embodied agent, the robot itself, needs to blend in or be an integral part of a whole vast system. You need to clearly identify the roles of what is the robot doing, what's the human's going to do, right? Is he or she or them even in part of like that conversation, part of the task or to get the job done? So I think there are a lot of other things also go that right now everybody thinks of just like only concentrating, making the robot do the task, but it's so much more beyond that. I'll give you a concrete example is that, so we at Dexterity are doing truck loading, and the bottom line metric at that for per truck is how many boxes went inside the truck. Who loaded it, whether it was the robot or the human operator, doesn't matter at that point. And from a warehouse perspective, it is like what is the input of number of packages coming in, what is the output going in per day, and how many you can process. That is the bottom number. As long as you are able to move these two, that's what your main goal is, and you need to work backwards from it. So I think, and these, especially in industrial setting, you have these hard constraints of or their time. There's like you need to get this done faster. You need to build, like you need to load more number of boxes inside the truck. Just taking that example clearly, but there's so much more that you need to work with, and you need to figure out the process flows or how you would interact with it. All of this matters a lot, and that also helps us define what you want to make and how it's going to operate, right? So I think those things are also something that are generally like initially overlooked, but we need to start considering them to how to make it usable, how to make it scale, and then and it's not just about one robot operating there, but it's about fleets of them operating there. There's a whole sets of technological setup to be like, you need to understand what are the requirements around that very, very clearly. So I think understanding that, thinking from that perspective, and again, I think I agree with Evan and Adolfo saying that data and being able to learn that, but you may not get data in certain scenarios. You need to just go be there and just collect tons and tons of it. So maybe, yes, I agree that end-to-end model is all about a bottom line data problem, but I'm saying once somebody has an end-to-end model, great, we'll have the data, right, at one point when we have collected it in real world, yes.
Okay, so the reason robots don't work, just to make sure, is sort of some mixture of usability and learning about the problem domain and just like doing the work, getting the data, that kind of stuff?
Basically, you want to build things that actually are something that's going to get the job done for it, because at the end of the day, whether it's the robots doing it or anybody or operators doing it, we need to be able to provide value for it. I have a return of investment on it. I have 5 people loading trucks versus I want the same 4 or 5 people loading 10 trucks altogether, working where you expand and more than what a human should be able to do is what the scaling should look like, in my opinion.
Cool. John, any thoughts?
Well, in our case, using modular systems, I can spend hours talking why our robots sometimes, in edge cases, could not work. Could be because of precision, location, navigation, whatever. but I say there is a component at the user level, and it's the adoption of the user. And to know and analyze those edge cases, how your user is going to accept your product when deploying in the real world, you're only going to know that when you actually deploy your product there. So I think why robotics are not working is because, and this could be controversial, because we're spending too much time in simulation and in laboratories, but to get the real problems and analyze why it's not working, it should be in production, in the real world. And know the community that every technology in early stages has drawbacks, downsides, and they must to be part of the development also of this technology of tomorrow.
Right. Okay, I like that. So what did the rest of you guys think? Do you think we're spending too much time in labs and simulations? It's okay. Do you need to answer that?
No, I think it's something you kind of have to do to push what's the frontier of robotics is. There is no way around it. But I think there is a balance to be, like, you need to strike a balance in saying, try to parallelly push the frontiers of robotics. Once you have made the advancements, also figure out a way to take them and put it to actual value. Like, it has to go back and forth and especially for startups or new companies that are building at the time, you need a way to start getting revenue. You need a way to start proving your tech out there.
Isn't that to his
faster.
point? That's putting it out in the world.
That's basically.
Right?
I'm agreeing.
Okay.
I'm complimenting what John said. So basically, yeah. So I think it is. But at the same time, that doesn't mean that you need to just stick to it. You also need to start investing, saying, "Oh, I think I'm doing this currently right now, but this is what's going to really scale better, or this will help them." So pushing that boundary, whether it's through, and especially that boundary of what we are going to push and what's possible, and bringing it over there is actually, in the last 4 or 5 years, is going crazy. Like our advancements we've made from end-to-end learning and everything. Yes, I see that's going to be very, very important. But I think taking that and putting into production, putting it to scale, that's going to be something we need to learn by doing. That's what I would say.
To have a bit of a hot take here, it could be the case. I kind of think that going out into the real world right now is a distraction. To just like getting you to the next scale foundation model right now. So within reason, right? I mean, the realities of supporting a product in production are vast and enormous. There's no way to get around that right now. And I think it is valuable to be anchored on real world use cases and see it like that. But right now, I think we are in a race to get enough diverse, interesting, useful data to train not even a ChatGPT, I'm talking a GPT-3 equivalent class model right now. And anything that is slowing down doing that is a distraction at this point. And because it is a theoretical, and because we kind of feel like we can know, if you have the data sources to go into making that happen, just focus on making that happen right now. Because really that is that sort of speed and the risk. The other kind of side that I think pulls that conviction is sort of from the belief that as you scale these models, a lot of these inductive biases that had been baked into all these prior systems kind of go away. This was I think a relentless trend that we've seen in language world, is that every time you removed some sort of inductive bias in the system and pushed the frontiers of compute and data into it, you really didn't need that as much anymore, or at least as not as much as you thought you did earlier on. And it seems to be the case that, again, because it's kind of using all the same architectures, that would probably be true in this domain as it is in the language domains too.
Okay, so hot take, the real world is a distraction. I know you want to say something, but Adolfo, you want to say your piece?
Yeah, I mean, I'm going to join in on the trend of we should deploy more. But I will caveat it that it depends on your goals as a company. I think if you want to build the world's best foundation model, maybe you're not in as big of a rush to deploy as a product-focused company. But if you want to ship a robot into a factory, you want to ship a robot into a home, you want to ship a self-driving car onto the road, all your engineers should be sprinting to get it into their home, a car they drive around in. Maybe not their factory, but whatever the equivalent of that is. Because if they're not, you're not going to deeply understand the true problems you have to solve in that deployment. So the more product focused your company is, the more you need to rapidly push towards deployment now, even if it's not with a customer, even if it's just internally, so you can work through all that pain and figure out what actually matters in your model and what doesn't.
Makes sense. You want to respond?
Thank you. Yes, I think I agree with Adolfo. And so whatever strategy is, whatever customer that you're trying to solve at that point, you're catering to, and you're building the product for, I think the strategy is largely dependent on that. And we have real problems looming in the next few years, starting from labor shortages to lot of average wages already going pretty high, or especially, and then there's a lot of turnover rates that are already there. So yes, I mean, if you are the applications that we want to give, I mean, the market that you already have right now that is there to be addressed in industrial warehouse logistics, that's not going to wait. They are looking for the industry is looking for solutions now. If we want to provide them, we gotta start understanding them better, asking what is there, understanding the problems, putting ourselves in the shoes of the operator there, the manager, the supervisor, the warehouse manager, the CEO, whoever it is. We gotta put what are they looking, how far they're looking, right? And trying to take each of their personas, each of their problems, and trying to make a product to solve it. And if robotics and if physical AI is the medium to give them that, I'm going to be the first standing in line, and a lot of folks who are here will be standing in line the first one and say, yeah, I want to provide value right now. What can I do, right? So I think that's what I strongly believe. Yeah. So no, the real world is not a distraction.
Do you want to respond or anything? Otherwise, we can keep going. Otherwise, we can move on.
Yeah.
Okay. Yeah. All right. Okay. Next question is, let's talk about safety. So So we have all these robots. We're trying to deploy them. Can end-to-end methods make them safe, or how can modular make them safe? Like, how are we going to how should we think about this in these contexts? And do you want to start?
Yeah, sure.
Yeah.
Okay. I think safety is probably one of the most primary underlying goal when it comes to working, especially with working with human operators. But safety has different aspects to it. There's safety about robots and the humans as well, safety about the robots itself, safety of the objects that they're manipulating, safety of the environment. There's like not hitting into things. There's a whole aspect of it. But one of the key things about safety is that it requires some guarantees that if this happens, the system is going to stop or not operate. But how do you take in something like, oh, that's old school? I mean, even now the rule-based robotics, which is basically what car companies and everybody has been doing for the longest time. Yes, it's revolutionary, but there's a lot of safety constraints that are put in for it. But now that we want to push the boundaries of the new research, one of the things is that, yeah, maybe we'll be operating closer, we'll be operating faster. How do you deal with this? So I think the question is not about taking a very strong stance, but about trying to do predictable degradation of the safe state. Like maybe there's a way where we can create systems that are able to predict or ensure that the system is operating under certain bounds that would end up triggering a safety setup for it. So yes, I think and when you create this layered AIs or like compositional structures, there are systems that then provide some like one is safety is like, oh, if you're closer than distance, stop. Sure, but then there are other things that we can do. Say, oh, I can slowly move the robot if somebody's approaching, and then there are like analytical, like algorithmic guarantees that also there from good old-fashioned engineering. And then there is a version that can happen that is more learned in saying, let me understand what the environment is. Is someone approaching? Can I predict that this is going to happen? Can I change my behavior for it? So I think that's where like the digital levels are going to be there, and the safety standards that are there right now I'm really glad there's a big push happening to revise them as the progress of the technology is also happening. So yeah, I mean, safety is always going to be something you have to always think about and balance the thin line of pushing what the robot should be able to do as well as trying to be safe, because at the end of the day, when you go to warehouses for us in industrial setting, the rules are rules. You have to operate under those conditions. So that's my take would be.
I think it's really interesting how the concept of safety has evolved in kind of the end-to-end era, right? Like, I think a lot of people in this room probably remember a time in which the idea that a black box model would take some output that you could never introspect it or ask what it was doing was a total non-starter, right? Like, that was like a hard line that was like baked into these systems as an assumption of safety. And here we have like Waymo and Tesla and Bedrock, right? Like moving these insane things with these end-to-end models. And they all have, all these like aforementioned places have amazing safety teams. It's just that the like evolution of it has changed. Now, how do you still work in a world like this? And like, all the techniques that we do in data shaping and augmenting it are like still there, but like this idea that it is this perfectly interpretable thing, I think has very much changed to kind of accept and evolve into this more end-to-end era. You kind of see the like also the further down the road again in language space, right? Like in ChatGPT world, hallucinations were a common form of like AI safety sort of adjacent alignment issues, right?
But they're still happening.
They are still happening. But I kind of point to like a very, very recent like releases around GPT-5's efforts to reduce hallucinations through this. And that was through like a lot of careful shaping of the data and the reward signals to like have this concept of like knowing when you're like not sure about something and digging in. But here again, it was done through these like data shaping techniques. So like this field is still here, but I think it looks very different in the end-to-end world than it does in this like perfect interpretability, like look at that exact log line that caused the problem type of mentality.
So the first thing I would say on safety is, at any of these sensors to interacting with the real world systems, I would argue no matter your design, it is very hard to actually make absolute guarantees. Most guarantees are guarantee with caveat. I will stop if a human is within this distance, as long as I saw the human, and as long as I thought the human was actually that close to me. So to some degree, it isn't an absolute guarantee. Now, can you make stronger guarantees with caveats and modular systems? Absolutely, but that comes with a trade-off, right? The one thing the end-to-end systems tend to be very good at is balancing trade-offs and understanding consequences, in a sense that, while they can't make that absolute guarantee necessarily that if I see a human within this distance, I will stop, they might be less prone to dropping the box on the floor and crushing something important when the human gets within 3 meters, because they understand that stopping what they're doing exactly right now doesn't work out. So I think when we think about safety in the context of end-to-end systems versus modular systems, we need to think about the risks that each system introduces and how do you manage that. If you're building a modular system, you should think really deeply about how you manage the risks of trade-offs, because I think that's inherently where you have weakness in the system itself. In an end-to-end system, you need to think really carefully about how do you try to make as close to absolute guarantees as you can about stuff that really matters, so you don't make a really dumb trade-off that looks absolutely nonsensical to a human. And second, the closer your system is to a black box, at least how much can you introspect its reasoning to some degree or let it attempt to explain your answer. Because with the cascading systems, well, you might not understand why your prediction system said the object could stop in a completely kinematically unfeasible world. You do at least know that it saw the object and saw how fast it was going, and the prediction system did something weird. In the end-to-end world, you need to start getting your model to express portions of its reasoning so you can understand what went wrong, so you can fix it and also explain the trade-offs it was making inside the black box.
Well, say more than that, honestly, I feel like a modern Waymo or full self-driving system feels a lot safer than some like handcrafted classical system that attempted to identify pedestrians all the time. And the more they drive, the more data that they get, the safer I will feel with that, because it will be a more robust detector of when there is somebody in a road, when it is just a mirage there.
John, what do you think? Let's give John a chance.
Well, I think in applications like ours, where we already have a modular systems deploying and ICs in the real world, it's easier to compare new approaches. I mean, you don't only need to evaluate your system because of safety, but it should be also tied to efficiency metrics. And if you already have an application in the real world, you have a baseline. And ICs, for safety reasons, it would be hard to find all edge cases of your sensors, your systems, or even your end-to-end model in a simulation, and it should be deployed and tested in the real world in a semi-controlled environment. It's mandatory. Yeah, that's it.
So I think I completely agree what Evan and Adolfo said, but I would say that sure, let's learn a model, but it doesn't need to be end-to-end. It just need to be a safety model. I mean, of course, that's great. So it's not about doing handcrafted modular or anything. It's not about handcrafted. It's about creating a sets of intelligence or skill set, essentially, I would say, that is easy to test under different conditions. Whether that is a handcrafted one, whether it's a learned approach, whatever it is, but at least there are guarantees that says if this happens, this will happen, and then that could be even it could be a composition of like a learned versus some level of basic handcrafted thing that if this happens, that is completely out of bounds, just stop the system, something like that. But it's not about. Sorry, go ahead.
Can you fully separate action from safety like that, though? I liked Adolfo's example of carrying the heavy box.
Yeah, I don't think you can have a separate model.
Yeah.
So I think the model would be more along the lines of saying, what is the current state of the system? And you interpret, okay, if I'm at the current, so there's a representation of what the current world is, the state, the digital representation of what it is, based on which you're going to take an action. But there could easily be a model that just says, oh, I am in this state, and have an interpretation for what not to do, for sure. But whether it doesn't need to, the output of this could be just want the human operator just not to go there, right? Or it could be something different about it. So, but the point is, like, you could try and understand as you go through these different situations, you will be able to, but at least there will be you can get your system running with some basic rules that are, even though conservative, it will still operate. And as you push this boundaries less, you can use different learned models.
Given that we now only have 2 minutes left, so
okay.
Let's. I think everyone can go around. Do you want to wrap up, or say if you changed your mind on anything, or I don't know.
Actually, my last thought was that this unfortunately opened another good can of worms. That is sort of this idea of a constellation of models, right? Sort of at the core of this modular approach here. To that, I would take the stance that we have seen that I think a more unified model that is truly end-to-end works better in a lot of domains. And I think it's also true in safety. So here's another example, like separate code and language models didn't work out super well, because in fact, to write good code and having good language and having good reasoning, these all helped each other. I think like the safety question in particular is about like having the model that kind of understands a valid set of actions and knows what is safe at the same time, like helps each other better. So I generally think, needless to say, I'm on the full combined end-to-end model side of this debate here.
In my opinion, it's not a race where one approach should win. It should be complementary, because one system can restrict the other. I think full end-to-end approaches have a lot of challenges. How you compile that in the edge, that's a big problem to solve, at least in the short term for deploying applications. But it's not a race. I see that in the middle term could be benefit for each other.
I'll say collecting data is very hard for robotics. It's not the same as LLMs. So if you're going to tie data to how good your safer system is, it's going to be a very different one. But it's a difficult challenge, and it's going to take a really long time. So like the approach that we think is going to be taking smaller chunks of compositional AI skills, and hopefully, as you get more data, merge them, if needed, into something end-to-end. So we are not. Again, my stance has not been either or. It's about what works. Let's do that. And if that at the end result in 5 to 10 years to be end-to-end, so be it.
Okay.
I guess I would end with, I'm on the constellation of outputs train, not the constellation of models. I think if you want to deeply understand how your model is working, get it to reason really well and manage trade-offs, the best way is to ensure that it's predicting more things than just the action, and understanding how the action relates with those predictions and really strongly encouraging it to align those well. The other thing I would end with is, I think we're all going to go out there and build these systems differently, and honestly, that's great. I could be wrong. Everyone else up here could be wrong.
Yeah.
And hopefully everyone's going to go out here and learn rapidly from everyone else around them. But at the end of the day, if we don't all go do things differently, then it's a one-size-fits-all box, and it's very unfortunate when that box doesn't succeed.
Yeah, that's great. All right, well, thank you, everyone.
Thank
Thanks
you.
This is a
Thank
fun
you.
discussion.
Thank you,
Thanks,
Chris.
everyone.
Thank you.